Last time we were together, we talked about the basics of weather. Now we're actually going to talk about specific types of weather. And before we really get into the different types of weather, you've really got to understand convection. Convection is warm air rises and cold air sinks. Now, when air is heated up through something called thermal expansion, it expands and becomes less dense. And if you remember, dense stuff is always found at the bottom, less dense stuff is found at the top. So the warm air rises. But we know as we go up in elevation, the air gets colder. So this warm air starts to cool down and it regains its density. And so it becomes dense and it sinks back down to the surface. But then it's near the heat source again. So it warms back up and rises. And so you get these currents, these convection currents that fuel pretty much all of the types of weather that we're going to talk about today. So the first one we're going to do is talk about clouds and precipitation. And you can see the very first steps are that convection. So air is warmed up and it rises. As it rises, the air cools down. And this is important because the water vapor that's in the air switches from being in the gas form to the liquid form. So it condenses into little teeny tiny water droplets. And those droplets form around the solid particles that we talked about in our last lesson. They're called condensation nuclei, and it can really be any type of solid, dust or salt or pollen, just something to kind of get that condensation started. And millions of those tiny droplets join together to form clouds. So the clouds are made of millions of teeny tiny droplets of water that are so tiny that they are able to remain suspended up in the air. So there's a ton of different types of clouds, but most of them are based off of the four major types. So if you're looking at thin, feathery clouds, those are cirrus clouds. If they're white and puffy, then they're cumulus clouds. If you look outside on a dreary day and it just looks like a sheet of clouds, those are stratus. And if they're rain clouds, those are nimbus. There's one more type of cloud that we're going to talk about in a second called a cumulonimbus cloud. And this has a really distinctive shape to it. They're very, very tall and they have a really wide cloud at the top, skinny in the middle, and wide at the bottom. So we've got these teeny tiny water droplets, but they start to collide with each other. And they get bigger and bigger and bigger until they're no longer able to remain suspended in the air, and they fall to the ground as precipitation. Now, what type of precipitation we get just depends on the temperature of the air near the cloud and the temperature of the air near the surface. So back to those cumulonimbus clouds. They're important because that's what we get thunderstorms from. And why we get thunderstorms from them is really due to the nature of the cloud. The clouds are really, really tall. So you end up, with this huge imbalance between the pretty warm air at the bottom of the cumulonimbus cloud and the really cold air up at the top of the cloud. So not only are these clouds created from convection, now they have convection currents actually within the cloud, which is what fuels these clouds to get bigger and bigger and what makes thunderstorms more and more severe. So in order to have a thunderstorm, you need a couple of things. First of all, you need a lot of humidity because remember, it's the water vapor that's making these clouds in the first place. You need the warm air to rise. So these are typically found on warm days. We don't have a lot of cold weather thunderstorms. And then you also need a lot of convection. You need that warm air rising and the cold air sinking to make those clouds bigger and bigger. Now let's talk about the dangers of thunderstorms. When you hear thunderstorms, most of us think lightning. So let's start with that one. Now, you do hear about people getting struck by lightning, but typically when we're talking about lightning, the danger comes in forest fires and property damage. So I do want you to take a moment and look at the picture there, the graphic of how to protect yourself in a lightning strike. You may want to pause the video for a second and just kind of read through those captions. Next up is hail. And hail comes from thunderstorms, again, because of the cumulonimbus clouds. So what happens is at the bottom of that cloud, you have rain that's getting ready to form. But if those rain droplets get caught up in the convection current within the cloud, they rise up to the top of the cloud where it's below freezing, so they freeze into tiny ice pellets, and then they fall back down. But if they get caught up again, then they go back up and they refreeze and they come back down. So eventually they fall out of the cumulonimbus cloud. How big the hail is just depends on how many trips did it make through the cloud before it fell. Just like with lightning, we're really not talking about human issues with hail. We're really just talking about property damage. The one that does cause a lot of issues with humans are flash flooding. So thunderstorms have a ton of power to them, and a lot of times they can just dump rain all of a sudden and cause flooding really, really quickly. Tons of runoff, very little infiltration. This is actually the main cause of thunderstorm-related deaths in the United States, and it's because people are dumb. They think that they can drive through water over the roads, but even up to or as little as 2 inches of rain on the road can actually take your car from a car to a boat that you can't steer. So the important thing is do not drive on roads where there's water crossing the road because you just don't know how deep it is. Moving on to tornadoes. Now, less than 10% of thunderstorms are considered severe thunderstorms, and then only a few severe thunderstorms are called supercells. And these are really, really, really powerful thunderstorms that have really strong convection currents. Supercells are the source of tornadoes. So every tornado comes from a supercell, but not every supercell makes a tornado. So make sure we understand that distinction there. Most tornadoes happen in the springtime, like we had a couple of weeks ago where tornadoes came through North Carolina. They tend to happen in the late afternoon or evening where the temperatures are the warmest and they're cooling down rapidly, but they can happen any time of day. And there's certain parts of the United States that are more prone to getting tornadoes than others, and that is Tornado Alley. It's just an area that has that combination of lots of humidity and lots of heat that really fuels those storms to start. Now, like I said, not every supercell turns into a tornado, but if there is going to be a tornado, it's going to be at those supercells. So meteorologists look at radar images for those distinctive hook shapes of the storms. And I've got 3 of them circled there so that you can kind of see what that hook shape looks like. Like I said, we don't know if those are tornadoes, but if there is going to be a tornado in the area, it's going to be in one of those spots. A tornado watch is something that they put us under if they think conditions are favorable for a tornado. So we're having a thunderstorm. It looks like it's got power to be a tornado. But a tornado warning means that a tornado has actually been spotted in the area. So for us, that means one's been spotted in Wake County, and they would probably put us on a warning if one was spotted in Durham County or Orange County. Because remember, weather in general moves from west to east. So if there's tornadoes in the neighboring counties to the west of us, they want us to know that it's headed our way. Once again, you may want to pause and just kind of look through the different suggestions for tornado safety. Not all tornadoes are created equally. They're all devastating, but how devastating they are depends on how strong the winds are. So there's a scale called the Fujita scale, not fajita. Everybody wants to call it fajita. The Fujita scale that measures storms. If you are familiar with the movie Twister, they talk about like F1, F2, F3. That's exactly what the Fujita scale is. It's just been modified a little bit, so now they call it the enhanced Fujita scale. And the pictures that I have there are from an EF5 tornado, the strongest that you can have. Our last thing that we're covering today are hurricanes. So they tend to happen in warm tropical oceans. Notice that California doesn't really get a lot of hurricanes because its water actually is cold. It comes down from the poles. So we get a lot of hurricanes because our water comes from the tropics. There's a bunch of different stages of hurricane development. Now, meteorologists are tracking these the whole time. We really start to hear about them when they hit the tropical storm stage, or obviously when it hits the hurricane stage. So the parts of a hurricane that are really distinctive are the eye. That's actually the calm center of the storm. We don't care so much about the eye, but we care about the eye wall. Those are the super, super, super fast moving winds and storms around the eye that produce the most winds and the most rain. Now they're tracking hurricanes just like they track tornadoes. So places that are likely to get a hurricane in the next day to a day and a half are put on hurricane watch. Hurricane warning are places that are going to get the storm in the next 24 hours. Because unlike how fast a hurricane is spinning, hurricanes actually move from point A to point B very slowly. We're talking maybe like 12 to 15 miles an hour. So they want to put people on alert for the next day or so because that storm is headed their way and they need to start preparing. So just like we had the Fujita scale, we have the Saffir-Simpson scale for hurricanes. And I don't really ever hear them use that term, but we hear them say things like, oh, that's a category 1, that's a category 2. So that's the scale that they're using there. So let's talk about the dangers of a hurricane. Here in North Carolina, flooding is a really big deal for us, whether it's coastal flooding from the storm itself, or if it's inland flooding, just kind of flooding those flat spaces, especially in the coastal plain. High winds are an issue, not so much for the wind itself, but for the debris that it can pick up and like crash through windows and stuff. And then storm surges. These are not exactly like ocean waves. It's just giant mounds of water that come up, and they have a lot of force behind them. In fact, the pictures on the right, or the picture on the right, are from giant ships that were actually washed 1 mile inland during Hurricane Katrina. So these mounds of water have a lot of force behind them, which means they can like smash houses, tons of debris. So this is actually what causes 90% of all hurricane related deaths. So I had to go through that super, super quickly, but hopefully as you do today's assignment, you'll get a more well-rounded knowledge of each of those different types of weather.